Okay, this is third period lab, and we are Friday, the 22nd. Okay, so I'm going to tell a story a little bit, but before I do, we are talking about the way the Earth has been changing over Earth's history. We started to learn about 4.6 billion years as an age for Earth, and we're going to learn a little more about continents moving around, the way the plates move. But the three things that we've learned so far is the type of boundaries. Okay, the transform boundary where they slide past each other, the divergent boundary where they spread apart from each other, or the convergent boundary where they come together. Let's talk about that. Okay. So what we're going to do is I've made some like little illustrations. You might want to call them cartoons, but let me tell you a story. All right. So like 20 million years ago, very long time ago, there was a familiar shape in the water, a great white shape, except that it was about 40 feet or longer. All right. This is the megalodon. Megalodon is an extinct animal. Extinct means there's no more. Extant means that there are a breeding population. So today, modern day, we have an extant population of great white sharks. More or less same body plan, but much larger, like school bus size larger, all right? So I brought something in, an actual megalodon shark tooth, okay? So megalodon, who are sharks are in this group called chondrichthyes. You don't need to know all this, but I just wanted to tell you. Chondrichthyes are in this group because they don't have bones. They have cartilaginous bodies, which means that they don't have anything that really preserves well when they die. When they break down, cartilage doesn't preserve in fossil record, whereas their teeth, which has dentine, all right, does preserve. So shark teeth preserve well. Now sharks have like rows of teeth, and it's sort of their design. When they bite onto something, they thrash their head around, they break teeth off all the time. And that might seem like a big deal to you and I, because, teeth are sort of, we only have two sets. Sharks have many sets, and as they break off a tooth, there's a row behind that just pops another one into place. So they have like this, kind of like a production of more and more teeth always coming in. So they're always losing teeth, and they're always kind of popping them back into place as they lose them. So let's tell a story that a big megalodon shark tooth like this, let me get the camera held a little differently. Oops, sorry. I used to be a cameraman. Terrible footage, I know. Okay, so let's say that this shark tooth comes out of a shark. Let's say 20 million years ago, megalodon bites into something. He's thrashing around, he's tearing into it, and one of these teeth kind of sinks to the bottom of the ocean, sits right there, okay? So now, the bottom of the ocean 20 million years ago, let's just say that there's a plate moving this direction and a plate moving that direction. Now when two plates converge, they come together, one of two things could happen. You could get subduction, where one of the plates goes under the other, or you get this uplifting, okay? So where they actually don't subduct, they actually start to come upward. All right, so now we're gonna scooch on over here. There's our tooth, all right? Now we're talking 15 million years ago, all right? So we're coming closer towards present day. Those two plates, instead of, heading towards each other, they're starting to move upward, all right? So you get this uplifting. So you got pressure coming this way, this plate from that way, this plate's going that way, and it's forcing the whole process upward, all right? Moving on, 10 million years ago. So we started with 20, now we're 15, now we're at 10. 10 million years ago, after enough time, this is starting to rise upward even further, okay? There's our tooth, just for reference, still underwater. Moving closer towards the future, current day, 5 million years ago, all right? After all this time, it's actually protruding up through the water. And if you were on, this location 5 million years ago, like on a boat or something, you would just see like this little island popping up, not seeing what was underneath the ocean, this large mountain. But there's our tooth, all right? So now, modern day, today, here's our tooth. Notice there's no ocean anywhere. In fact, it's so dry that, there's homes and cities and things like that. Let me go back to here. So when this was coming upward, it was actually displacing the water. So, the ocean's here, and as this pops up, the water starts to get pushed that way and get pushed that way. So as this comes up, the further it comes up, the further away the ocean gets, all right? So the point I'm trying to say is that when you get into the mountain range and you find marine life, it could be a shell from clams, it could be any kind of marine life, or a shark tooth, a megalodon shark tooth, that was originally deposited at the bottom of the ocean, now located in a current, mountain range. That is evidence that this area was once underwater, and this is the process that brought it from an ocean floor all the way to a mountain range. Now, when you're looking at these drawings, I'm just showing you one peak, and this, kind of just gives you a better idea. These are, more accurate to how mountains form, and this is what they call buckling or folding. So when you've got, the direction going this way, and this set over here is coming this way, it starts to bend right here. So this, it buckles upward, so on and so forth. So you get these mountain ranges, not just a single mountain, all right, just so for clarity. So I want to tell you another part of the story. This is a caliper, and we measure things with this particular instrument. We're going to go to the midline, which is more or less like the midsection of this tooth, all right? And if I measure it, it's hard to do with one hand, works out to be about 50 millimeters, all right? This is not the biggest megalodon shark tooth that I personally have owned. I owned one that was 150 millimeters across. Let's see if I can do this with one hand. 150. Look at the size of that. So remember, that's the measure from here to here, okay? Look at that. So imagine a shark tooth like this with the gum line here. So as impressive as this is probably a juvenile, a very young megalodon. It is megalodon, but it was probably a very small megalodon when he lost it, or when they lost it. So megalodons are just this enormous version of a great white shark. I brought these in just for scale. So these are other little small, these are fossilized teeth. I believe these are sand sharks. Okay, so very, very small. So when we find fossil evidence of marine life in areas that's nowhere near current marine location, meaning like the ocean's nowhere near modern day, to find evidence of marine life tells you something. So if you find yourself in a mountain range, you can say to whomever's nearby, this was all once underwater. This is once the bottom of an ocean floor, which is why we find marine life here in the mountains. Fun fact. Okay, so there's a question that I'm going to ask you that has to deal with what process is this closely related to? Is it divergent where they go apart? Is it transform where they slide past each other? Or is it convergent where they come together? Okay, so with that, here comes the uploaded video. You're going to watch this later, so I'm not going to tell you to do the assignment, but you're going to do the assignment. Everybody's going to do the assignment now, and the assignment is to be done until this is ready for you to do before you leave. This is your grade, though, okay? Here we go.